Greetings and welcome to the O-Level Revision series. This is part 2 of the chapter on polynomials, and in this video we'll be looking at polynomial long division as well as the synthetic division shortcut. Specifically, the success criteria for this video would be for students to be able to divide a polynomial by a linear or quadratic factor using the long division algorithm. Thereafter, they should be able to express that polynomial in the form of divisor times quotient plus remainder. As an optional learning objective, students can also learn how to divide a polynomial using the synthetic division method. Let's begin with a quick recap of video 1. We have learned that monomials are the building blocks of polynomials, and each monomial comprises of a coefficient, a variable, and an exponent that has to be a non-negative integer. Polynomials are the sum of monomial terms. The degree is the highest exponent in the polynomial, and the coefficient of the highest exponent term is known as the leading coefficient. We have also learned how to add and subtract two polynomials together by adding or subtracting their like terms. We have also looked at the rainbow expansion method for polynomial multiplication. Now, before we go into the long division of polynomials, we need to go back in time to arithmetic long division. Let's take 20 divided by 3. 20 is the dividend and 3 is the divisor. We will get a quotient of 6. Now 6 times 3 gives us 18, and we subtract 18 from 20 to get a remainder of 2. In primary school, we have also learned that the dividend is also equals to the divisor times the quotient plus remainder. So for in this case, 20 is equals to 3 times 6 plus 2. This is also quite helpful when we want to represent improper fractions in the form of mixed fractions. So in this case, 20 divided by 3 is equals to 6 the quotient plus 2 the remainder over 3 the divisor. Polynomial long division mirrors its arithmetic counterpart, and it comprises of 3 steps that we will keep repeating until the end. Step 1. We start by dividing the leading terms. 2x cubed divided by x. This gives us 2x squared. Next, step 2, we will multiply 2x squared with x minus 3, the divisor. This will give us 2x cubed minus 6x squared. Step 3, we will subtract 2x cubed minus 6x squared from 2x cubed minus 9x squared. The 2x cubes will cancel each other out. Minus 9x cubed minus negative 6x squared gives us negative 3x squared. Lastly, we bring 13x down, and we will repeat step 1 again. Once again, we divide the leading terms. Negative 3x squared divided by x gives us negative 3x. Step 2, we take negative 3x and we multiply it by the divisor x minus 3. That gives us negative 3x squared plus 9x. Step 3, we subtract. Subtracting, the negative 3x squares will cancel out, and 13x minus 9x gives us 4x. Lastly, we bring the negative 5 down. And we're going to repeat the cycle one last time. So back to step 1, division. We will take 4x divided by x. This gives us 4. 4 will multiply to the divisor x minus 3. This gives us 4x minus 12. And lastly, step 3, we're going to subtract 4x minus 12 from 4x minus 5. And this will give us 7. We stop here because 7 cannot be divided by x without going into the negative powers of x for the quotient. Now let us recall here that we can also re-express the dividend in the form of divisor times quotient plus remainder. So in this example, we're going to get x minus 3 multiplied by 2x squared minus 3x plus 4 in red, plus 7 the remainder. If we were to expand the right hand side, we will get back the dividend. Also note that the degree of the divisor is 1 and the degree of the quotient is 2, and together their sum will give us the degree of the dividend. We also note here that 7, the remainder, has a degree of 0. The degree of the remainder must always be less than the divisor. That also tells us when to stop polynomial long division. Now we move to a guided practice 1. In this question, we want to divide 4x cubed minus 4x squared minus 13x minus 13 by 2x plus 1. At the end of this long division, we also want to re-express this polynomial in the form of divisor times quotient plus remainder. So you can choose to pause the video here and try to do this on your own, or to do this alongside with me. So let's begin. We first look at the leading terms. So 4x cubed is going to divide by 2x, and this will give us 2x squared. Next, step 2, we're going to take 2x squared and multiply it by the divisor 2x plus 1. This will give us 4x cubed plus 2x squared. Now we move on to step 3. We subtract. So 4x cubes will cancel each other out. Minus 4x squared minus another 2x squared. This will give us negative 6x squared. And we bring negative 13x down before we start the cycle again. Step 1, we divide the leading terms. Negative 6x squared divided by 2x gives us negative 3x. Step 2, we multiply negative 3x by the divisor 2x plus 1. That gives us negative 6x squared minus 3x. Step 3, we subtract negative 6x squared minus 3x from negative 6x squared minus 13x. The negative 6x squares will cancel, and negative 13x minus negative 3x, that gives us negative 10x, and we're going to bring the negative 13 down. Step 1, division. We divide the leading term, negative 10x by 2x, that will give us negative 5. We multiply negative 5 by the divisor 2x plus 1, that will give us negative 10x minus 5. And lastly, we subtract. So we will subtract negative 10x minus 5 from negative 10x minus 13, and that will give us negative 8, which will be our final remainder. Lastly, we need to express this in the form of dividend equals the divisor times quotient plus remainder. This will give us 2x plus 1 multiplied by 2x squared minus 3x minus 5 minus 8. And that's our final answer. Now, just like how long division can help us express an improper fraction into a mixed number in basic arithmetic, a preview of what is to come is that polynomial long division can also allow us to convert an improper algebraic fraction, like this form, into a proper algebraic fraction later. This will be quite important for partial fractions. Moving on to guided practice 2. You're encouraged to pause the video here and give this a good try before going through the solution with me. Let me now go through the solution. So first thing we need to notice is that in the dividend, the x squared term is missing, so we need to add it back in. We'll just add a 0x squared inside. Before we begin step 1, we need to divide the leading terms. 3x cubed divided by x is going to give us 3x squared. Next, we multiply that by the divisor, and that will give us 3x cubed minus 6x squared. And that we will subtract from 3x cubed plus 0x squared. So the 3x cubed will cancel out, and 0x squared minus a negative 6x squared is going to give us positive 6x squared, and we bring the negative 8x term down. Then we start again. We divide the leading term 6x squared by x. this gives us 6x. We multiply 6x by the divisors x minus 2 to get 6x squared minus 12x. And we subtract that from 6x squared minus 8x. The 6x squared terms, they're going to cancel out. Negative 8x minus negative 12x will give us positive 4x, and we bring the 4 down. Next, we go back to division. 4x divided by the leading term x will give us 4. Multiply. 4 times x minus 2 will give us 4x minus 8. And lastly, we subtract. And 4 minus negative 8 will give us 12. And that will be our remainder. Next, we're going to express this in the form of dividend equals to divisor times quotient plus remainder. And that simply just gives us x minus 2 times 3x squared plus 6x plus 4 plus 12. Now let's look at the same problem again, but this time using the syntactic division method. Now this method is actually the same as before, but the working is a lot more simplified. And instead of writing the terms, we're going to construct a table of just the coefficients. So in the first row, I'm going to transcribe the coefficients of the dividend in the same order. So we have 3, 0, negative 8, and 4. Do remember the very important 0 that represents 0x squared. And you can see that each column represents terms of different powers. So we have 3 representing 3x cubed on the left, with 4 on the right representing the constant 4. Next, we're going to need the divisor. So we're going to set the divisor x minus 2 to be equals to 0, and that will give us x equals to 2, and we copy that here in this left-hand column. Now we're going to start the algorithm, and the algorithm basically alternates between addition and multiplication. We're going to add the columns and multiply diagonally with the divisor 2. So it goes like this. So 3 plus 0 gives us 3. 3 times the divisor 2 gives us 6. 0 plus 6 gives us 6. 6 times the divisor 2 gives us 12. Minus 8 plus 12 gives us 4. 4 times 2 gives us 8. 4 plus 8 gives us 12. You see that we have the first 3 numbers that I've indicated in red. This is going to represent our quotient. So we're going to get 3x squared plus 6x plus 4. And the last number that I've highlighted in green, that will be our remainder. Now, in addition, I'd like to also emphasize that this method, while it looks easier, I find that it doesn't quite develop conceptual understanding. Additionally, when we reach quadratic divisors later, it's going to get a bit messy. Now let's go back to the same question as guided practice 1. But now I would like to invite you to try doing this question by using the syntactic division method. Pause the video here and give this question a good try. Now let me walk you through the steps. So step 1, we're going to transcribe the coefficients. So we have 4, negative 4, negative 13, negative 13. Now we need to set the divisor to 0. We get x equals to negative half, and we copy it here. Now we're going to alternate between adding the columns and multiplying diagonally with the negative half that we got from the divisor. So 4 plus 0 gives us 4. 4 times negative half gives us negative 2. Add the columns together, we get negative 6. Multiply by negative half, we get 3. Add the columns again, we get negative 10. Multiplied by negative half, we get positive 5. And lastly, negative 13 plus 5 gives us negative 8. Simple. But not so simple is finding the quotient. You would think that the 3 red numbers would represent the quotient, but it doesn't. The problem is that if the quotient starts with 4x squared, 4x squared times the divisor of 2x is not going to give us 4x cubed. So we actually have to halve all the numbers in red to balance this equation. So it's going to be 2x squared minus 3x minus 5. So it's the same numbers, 4, negative 6, and negative 10, but you multiply them by half to get the quotient. The remainder, on the other hand, you don't have to do anything. It's just -8. Now let's look at guided practice 3 for quadratic divisors, which is going to be more common for partial fractions later. So the long division method is exactly the same. We're going to cycle between the 3 steps of division, multiplication, and subtraction. So step 1, divide the leading coefficients. 6x cubed divided by 3x squared gives us 2x. Next, we multiply 2x with the divisor. So 2x multiplied by 3x squared minus 2x plus 1 gives us 6x cubed minus 4x squared plus 2x. Next, we subtract. When we subtract, we're going to get negative 3x squared plus 6x, and we're going to bring down the constant term, negative 9. Now we start again. Step 1, division. We divide the leading terms, negative 3x squared by 3x squared. So this will give us negative 1. Multiply negative 1 by the divisor. We are going to get negative 3x squared plus 2x minus 1. And we subtract, and we're going to get 4x minus 8. We will stop here because the degree of the remainder is 1, and that is already less than the degree of the divisor. If we were to proceed, the quotient is going to start having terms with negative powers. And same as before, we can rewrite this entire long division form in the dividend equals to divisor times quotient plus remainder form. So the dividend is going to be equals to 3x squared minus 2x plus 1 multiplied by the quotient of 2x minus 1 plus the remainder of 4x minus 8. So let's do this one more time again, but this time using the synthetic division method. Now this, I have to say, is highly not recommended, but for completeness sake and because a lot of students bug me on this, it can be done. So first, you need to transcribe the coefficients of the dividend. So we have 6, negative 7, 8, and negative 9. Then the trouble begins. You can see that I've added 2 rows below the first row. So this, we need to first get this number 2/3 out. Where does this 2/3 comes from? It comes from the coefficients of the x and x squared term. So negative 2 divided by 3. And we have to multiply that by negative 1. So that gives us 2/3. Next, we need this negative 1/3. Where does this come from? It comes from the constant term in the divisor 1 divided by the leading coefficient 3, and we multiply a negative 1. So that's where these 2 purple numbers come from. Then we can start the algorithm. It's about the same. We are still going to add the columns together, but when we multiply, we got to do 2 sets of multiplications for the 2 purple numbers from the divisor. So the first column is easy. 6 plus 0 is still 6. Now we got to multiply 6 by the 2 divisor number and put them in the correct place. So for the multiply by 2/3, we're going to go with just at the x squared column. So 6 times 2/3 gives us 4. 6 times negative 1/3 gives us negative 2. And we can add the next column together. So negative 7 plus 4 is going to give us negative 3. And this negative 3, we got to multiply it by the 2 numbers again. Negative 3 times 2/3 will give us negative 2. Negative 3 times negative 1/3 gives us positive 1. And the last 2 columns on the right, where we can just add the columns together, is going to give us 4. 8 minus 2 is 4. And negative 9 plus 1 is negative 8. Now the 2 numbers in green, 4 and negative 8, this is going to represent our remainder, 4x minus 8. However, 6 and negative 3 in red does not represent the quotient. This is because if it was 6x minus 3, 6x, the quotient multiplied by the leading term in the divisor 3x squared, does not give us 6x cubed. And we have to preserve the leading coefficient of the dividend. So what we need to do is we need to multiply the 2 numbers in red by 1/3 or essentially divide them both by 3. So the quotient is actually 2x minus 1. So now it's your turn to practice. In the info section below, I've included a link to my website and an applet that will generate random long division questions. Try them out and check the applet for the answers to see if you have done it right. Now let's reflect on the success criteria that we've set out at the start of the lesson. Are you now able to divide the polynomial by a linear or quadratic factor using the long division algorithm? Are you then able to represent that polynomial in the form of divisor times quotient plus remainder? And lastly, as a bonus option, are you now able to divide a polynomial using the synthetic division method? Now, if you have any questions, post them in the comment section below. We have now come to the end of the video for part 2. Stay tuned for part 3, where we will go through the remainder theorem and we'll look at how it results from polynomial identities. Now, if you've enjoyed the video, don't forget to like, share, and subscribe to the channel. Thank you and have a great day of learning.